Welcome all. Today I'll discuss GATE 2024 XE all thermodynamics questions. That is XEE all 22 questions. Now I read this thermodynamics paper. It's a very good question paper. So it is a mixture of some easy questions, some moderate questions, and some very good questions also. Let us discuss neatly all these questions. Let us start. So there are 22 questions. I'll do each and every question in a systematic and detailed manner. Please read the first question. Okay. The first question is, now observe here. A heat source at a temperature TH, okay, a heat source at a temperature TH transfers the same amount of heat to sink under following conditions. So there is a heat source at a temperature TH and it is transferring heat under two conditions. So there is sink at a temperature TL2 and another sink, case A is sink at temperature TL2 and another is sink at temperature TL2. Okay. Now he has clearly given that TL1 is less than TL2. Okay. Now he says which one is more reversible. It's a very good question and simple question. We know that the loss of available energy or increase in unavailable energy is given by Q1 T naught into T1 minus T2 by T1 T2. So what is this? I'll tell you. Q1 is the amount of heat transfer. T naught is surrounding temperature. This I have already derived in our regular classes. Surrounding temperature. And here T1 is the higher temperature source temperature and T2 is the lower temperature. In this case, there are two lower temperatures TL1 and TL2. I have told you very clearly, larger the temperature difference, larger is the loss or more is the irreversibility. So as the temperature difference is large, it will move far from reversibility. So clearly he said, in case A, it will be Q1 T naught into T higher temperature. The higher temperature is given as TH and the lower is TL1 by T1 is TH and T2 is TL1. And in the case B is same Q1 T naught, T higher minus T lower is TL2 by TH into TL2. Okay. You know, my dear students, if you observe, the temperature difference is large. The temperature difference is large. The difference is large in first case. Sorry, case B. First case, the difference is large because TL1 is less. As TL1 is less, this difference is large. The loss of availability or the irreversibility will be more in case A. Whereas the difference is less because TL2 is small. As TL2 is small, the TL2 is less, the difference will be less and the loss will be less. Larger the temperature difference, larger is the irreversibility. This can also, therefore, case B is more reversible. Please note down that whenever there is a heat transfer with finite temperature difference, it is always irreversible. So there is the entropy generation in case A and case B. But in case B, as the difference is small, the irreversibility is less, entropy generation is less, but still it is positive. So therefore, if you observe clearly, this is the heat transfer. So the source is transferring TH, and this is our, let us say, TL1. Now, what is TL2? Look at carefully. So let us say this as TL2. And what is TL1? It is lower than this. So therefore, this is the second case. Understand carefully. This is TL1, this is TL2, and this is TL1 because TL2 is more. So therefore, if you see, observe very clearly, the loss of available energy is more when the difference is large. So therefore, a generation is more in second case. So second case, matlab A case here. So as the difference is very small, I repeat, as the difference is very small in B case, for example, I take TH as 500 Kelvin and TL2 as some 400 and TL1 as some 300. See the difference. So in case A, it is 500 minus 300 more. In case B, 500 minus 400. Case B is less. So case B is more reversible. Of course, it is irreversible. It is not purely reversible. Whenever there is a heat transfer with finite temperature difference, it is always irreversible. So therefore, he is comparing A and B. Now let us answer. Okay. Case B is the difference is less, so more reversible. Of course, there is an entropy generation which is positive. So reversibility is same in both. No, sir. Case B is less reversible. Yes, it is less reversible. Less reversible bola hai. No, sir. No, sir. No. Case B is less reversible. No. Compared to case A, case B is more reversible. Case B, this also wrong. Case B is more reversible with entropy generation greater than zero. So C is the right answer, my dear students. C is the right answer. Is it okay? Chal. Now let's move to the next question. Next question. The van der Waals equation is given and he is asking, it's a simple question, sir. If you look at this question or this equation, pressure is a function of R is constant, B is constant, A is constant. It's a function of volume and temperature. Pressure is a function of volume and temperature. And you have studied in thermodynamic relations. Three theorems I have given you. If Z is a function of xy, then we know very clearly dou x by, from the theory of partial differentiation, dou x by dou y at constant z into dou y by dou z at constant x into dou z by dou x at constant y is equal to -1. Now you know very clearly this is from the theory of partial differentiation. So in place of z we have p, in place of x we have v, in place of y we have t. Now apply this. यहाँ पे put करना. So therefore dou v by dou t, same I am applying. Dou v by dou tp into dou t by dou p at constant. Tp means v into, just I am substituting in this. So z is p, x is v, y is t. So therefore dou p by dou v at constant temperature is equal to -1. Dou v by dou tp, dou p by dou vt, dou t by dou pv is dou p t by dou p is -1. So B is the right answer. -1 is the right answer. Now next. The temperature of a 10-gram water in an insulated, this is a good question, sir. The temperature of 10 gram of liquid water in an insulated container is raised by 5 degree by stirring. Insulated. The amount of heat transferred is, now you may be wondering, sir, idhar dekho, it is completely insulated. And we have water, 10 gram of water. And there is a stirrer. Okay. Okay. This water is mixed with the help of this stirrer. Understand carefully. This is a paddle wheel work. So work is transferred to the system. From the boundary, through this boundary, work is transferred to the system. And it is insulated. So heat transfer is 0. You may be wondering, MC delta T karke. Idhar dekho sir. D dash Q is equal to du plus D dash W. You may be thinking that du is MC delta T, but that is giving me work. Not because work is done. Paddle wheel work is on the system. Because of the transfer of this work, there is an increase in internal energy. Okay, but observe clearly. He is asking amount of heat transfer. So the heat transfer, it is perfectly insulated. So there is only work transfer. There is no heat transfer. So the heat transfer is 0. Good. Go to the next question. Now, in the figure shows 4 different processes labeled as 1, 2, 3. 1, this is process 1, this is 2, and this is, okay, labeled as 1, 2, 3, 4. Okay. The curves are labeled as T1 isotherms. Look at such. This is one isotherm, this is one isotherm, this is one isotherm. Okay. For which of these the magnitude of internal energy change, is asking internal change is highest. Okay. Now let's observe. I have already told you in my regular class. What did I tell you? So this is volume and this is temperature. So you know it is a rectangular hyperbola. Isothermal process for an ideal gas is given by rectangular hyperbola. Mass is constant, R is constant, isothermal temperature is constant, PV is constant. So it is a rectangular hyperbola. So there are 3 temperatures given, my dear students. Let us see what are those 3 temperatures. T1, T2, T3. Exactly. So this is T1, T2 and T3. Just understand. Let us see which temperature is highest. So everywhere along this curve, T1 temperature is constant and its value is T1. Everywhere on this T2 is constant. Everywhere on this T3 is constant. Now we have to see which temperature is maximum. I repeat, which temperature is maximum we have to see. So for that, you just draw a constant volume line. Okay, let me take this as 3. Let me take this as 2. And let me take this as 1. So everywhere I can write V1 is equal to V2 is equal to V3. It is a constant volume. This pressure is P3. This pressure is P2. This pressure is P1. Okay. You know very well, PV is equal to MRT. Okay. PV is MRT. For this process, which is a constant volume process, when volume is constant, mass is constant, R is constant, pressure is directly proportional to temperature. Larger the pressure, larger is the temperature. For a constant volume process, now I have points 1, 2, and 3. The pressure at point 1 is more. When pressure is more, temperature is more. It means T1 is more than T2. Pressure at point 2 is more than pressure at point 3. P2 is more than P2 is more than P3. When P2 is more, T2 will be more than T3. So I can safely write that T1 is greater than T2 greater than T2. This temperature is more. Then we have this. Then we have this. T1 is greater than T2 greater than T2. T1 is more. This is more. Okay. Now we have identified, and you know, for an ideal gas, how do you know it is an ideal gas? Clearly, he said in the problem, ideal gas. For an ideal gas, internal energy is a function of temperature. And he is asking, look at it. We can write du as mCv dt. And you know, gas is same, so Cv is not changing, mass is not changing. The change in internal energy is directly proportional to temperature. Larger the temperature difference, larger is the internal energy change. Why are you calculating larger internal energy change? Because he said calculate the magnitude of highest internal energy change. Matlab, the process in which the temperature difference is maximum, the internal energy will be maximum. Let us see process 1. For process 1, look at the difference. For process 1, it is from here to here, here to here. So it is T1 minus T3. Because it is from this end to this end. It is going from this end to this end. But this end to this end, this is at T1, this is at T3. So next, let's go to second process. For second process, it is coming from 2 to 3. 2 to 3 means it is T3 minus T2. T3 minus T2. And let's go to third process. Third is going from 3 to 2. So therefore, it is T2 minus T3. And fourth process, 4 is coming from 4 to 1. 4 to 1 means T2 minus T1. Now you see, my dear students, the highest temperature difference is for process 1. If you see, definitely, you know very well, T1 is greater than T2 greater than T3. So where is the temperature difference maximum? It is maximum from 1 to 3. So 1 to 3 has maximum temperature difference. So process 1 has greater the temperature difference, larger is the internal energy change. So process 1 has the larger internal energy difference. Is it okay? Now let's go to the next question. Read this question. Please read this question. This is from application of thermodynamics, that is Rankine cycle. Don't worry. So a power plant operates on a simple ideal Rankine cycle. If superheating is added to the cycle, which one is correct? There is a power plant. First he said it is operating on a simple cycle. Let me show you Rankine cycle. The simple cycle is isentropic expansion, constant pressure heat rejection, isentropic pumping. Okay. Now then constant pressure heat supply. Let this be 0.1, 0.2, 0.3 and 0.4. Okay. Now look at carefully. This is a simple cycle. Now he says superheating is added to the cycle. Let's go for it. So superheating is done from 1 to 1 dash. This is superheating. Chalo, this is a superheated cycle. So let this be 1 dash and let this be 2 dash. So old cycle is, means original cycle is 1, 2, 3, 4. I repeat, 1, 2, 3, 4. And superheated cycle is 1 dash, 2 dash, 3, and 4. See what is happening. You know, constant pressure lines diverge. So definitely, this is the turbine work in old cycle, and this is the turbine work in new cycle. So as the constant pressure lines diverge, this moves away. Thereby, the expansion work is increasing. So the point number 1 is there is an increase in turbine work. Increase in turbine work, because originally it was expanding from 1 to 2, now it expands from 1 dash to 2. Definitely this work is more than this work. Point number 1. Observe carefully. Are you touching pump? Pumping is from 3 to 4. Whether it is a original cycle or new cycle, we are not touching 3 4. Pump work is same or constant. Next, what is happening to the efficiency? You know, my dear students, when I teach you power plant, I'll be explaining very clearly, already have done so many times. The efficiency for a given temperature of heat rejection, the efficiency is a function of mean temperature of heat addition. Larger the mean temperature of heat addition, higher is the efficiency. So now you are adding, in old cycle, you are adding from 4 to 1. In a new cycle, you are adding from 4 to 1 dash. So this is the additional heat, and this heat is added at higher temperature. So therefore, the mean temperature of heat addition increases. As the mean temperature is increasing, the efficiency is also increasing. And see point 2. Point 2 is moving to right, means dryness fraction is increasing. Point 2 is moving to the right, dryness fraction is increasing. What does dryness fraction increase mean? Moisture is decreasing. Moisture is nothing but liquid. When dryness fraction is increasing, vapor content is increasing, liquid moisture content is decreasing. So what are the results? Superheating. Turbine work is increasing, pump work is same, efficiency is increasing due to mean temperature of heat addition, dryness fraction is increasing, and the moisture is decreasing. Let's go and answer. Pump work increases, wrong. Pump work remains same. Turbine work increases, cycle efficiency increases, moisture content increases. Be careful, my dear students. See, देखो, pump work, turbine work increases, cycle efficiency, moisture content decreases. See option B and C. See option B and pump work decreases. Correct. See option B and C. Very smart. You are always in examination fear. तो आपके माइंड में तो आता है कि dryness fraction is increasing. Okay, dryness fraction is increasing. Suddenly you don't see moisture content, and directly you take the moisture content is increasing. You might have thought that the dryness fraction is increasing. But actually he said moisture content. Moisture is liquid, but liquid is decreasing. So this is wrong. Pump work remains same. So always remember, every word in examination is important. Whenever you stay calm and cool in examination, ideas will come. Do not get excited. So pump work is same, turbine work is increasing, correct? And the efficiency is increasing, moisture content decreases, or dryness fraction increases. Moisture means liquid content is decreasing, the point is moving to vapor region. So therefore option C is correct. Very good, sir. Next. Now, a closed system is undergoing the process given by PV power gamma is equal to constant. And you know, I shout like anything in class. I shout like anything. To apply this equation, always 3 conditions must be satisfied. The working fluid should be ideal gas. The process has to be reversible, and the process has to be adiabatic. Out of these 3 conditions, even if one condition is not satisfied, the problem, I cannot apply this equation. I cannot apply this equation. So look at it. He's asking, already he said, which of the following statements are true? And he said, a closed system undergoes unknown substance, adiabatic process. Already adiabatic is given. Now, what are the other conditions to be satisfied? Ideal and reversible. The substance is an ideal gas and the process is reversible. Yes, the substance has to be an ideal gas and the process is reversible. It is absolutely correct. The substance is liquid. No, sir. I cannot apply. Substance is non-ideal. No, sir. The substance is an ideal gas and the process is not reversible. No, process has to be adiabatic. Reversible. Okay, chalo. Take this question. This is a very good question. Please read the question. Now, too rigid, impermeable. What does impermeable mean? No flow. No mixing, no mixing. This is a smart question, sir. And the focus should be in this question on two words. So, क्योंकि I'll tell you what mistakes can we commit. Too rigid, rigid. Focus should be on rigid, impermeable. Impermeable means it cannot flow and mix. Two rigid containers A and B are filled with ideal gases. They allow exchange heat only, means no question of work transfer, only heat exchange with each other, and not with surroundings. They allow heat with each other, means A and B can transfer heat with each other, but those systems A and B, they cannot transfer with surroundings, means internally they are transferring with each other. Okay, now PV, NTR, pressures and temperatures. Now N is number of holes at equilibrium. He is asking which one is correct. Answers no, sir. My dear students, look at carefully. It's not this. You may be thinking that I have done so many questions of this type. Let it be insulated. Let it be insulated. Let it be gas A and gas B. Now, if this is a moving partition, there is a work transfer. So he clearly said there is heat transfer and rigid. तो ये कंटेनर्स रिजिड है तो ये पॉसिबली नहीं है सर. So therefore, if this is the case, then not only pressure is same, but temperature is also same at equilibrium. But this is not the case. But this is not the case, sir, because he clearly said there is only heat exchange. Let us take this as container A. Let the pressure of A be PA. Let the volume of A be BA. Let the temperature of this be TA, and number of moles of this be Na. Excellent, sir. Now, let us take another container, B. Let PB be the pressure, VB be the volume, TB be the temperature, and number of moles be TB. Now look at it. And clearly he said, this system is not allowing heat transfer with surroundings. Impermeable means this cannot flow, this internally they cannot flow. Impermeable, rigid containers, both are rigid containers. Now tell me, it's not the piston is moving or something like that. If that is the case, not only pressure is same, temperature is also same, but yahan pe they are not in direct contact. Only suppose this temperature TB is more, then there will be a transfer. If TB is more, it will be transferred like this. If TA is more, it will be transferred like this in between. And finally, when they reach equilibrium, what will be same? Only temperature is same. Finally, when they reach, because he says only there is a heat transfer between these two. Agar work bhi transfer hota hai, then pressure equilibrium will be there. But here there is only heat transfer. That is the key word here. Only with the heat transfer only. That's why when the heat transfer is taking place, it should transfer until thermal equilibrium is reached. So therefore, there is only thermal equilibrium in this case. And you also know, so this is correct. But please note down that PV is equal to NR bar T. So R, now, can I write this as PV by N is equal to R bar T? Yes, sir. So under equilibrium, temperature is already same. When temperature is same, R bar is universal gas constant. So under equilibrium, PV by N must be constant. Let me repeat, sir. Under equilibrium, already temperature, both after losing heat, one loses, other gains until they reach same temperature. Once the equilibrium is reached, my dear friends, once the equilibrium is reached, temperature is same. So already R bar is same. It is an ideal gas. Clearly, it is an ideal gas he gave. I know, sir. How? The ideal gas. So R bar is same. Finally, equilibrium is also, equilibrium temperature is same. When this is same, this will be constant. This will be constant. So PV by N is constant. Matlab PA, VA. We are taking N as small n, but in this problem he has given it as capital N. How does it matter? Is equal to PV by N, VB by NB. So this is one equation. This is another equation. So PA, VA by N is PA. This is a good question. It is the second question. लेकिन इसको ऐसा भी कर सकता, देखो सर, अगर ऐसा करता है, there are two gases. सुनो carefully. Insulated. इधर देखो. Next year, this may be a question. PA, BA, TA, PB, VB, TB, NB, whatever it may be, NA, NB. So now, there is a movable partition. When equilibrium is reached, tab kya hoga? Not only the temperature is same, but also pressure is same in that case. So this is a different case. and this is a different case because in this problem he said there is only heat transfer. Suppose the partition is moving, definitely the one which expands is doing work on the other. So therefore, in this case, it is not allowed. That's why I have not taken this case. Otherwise, there will be pressure equilibrium also. But in this problem, only these two are possible. Okay, chalo. Next. Take this question. The following data is, this is from RAC, refrigeration, air conditioning. A simple question, sirs. Okay, let me show you VC cycle. This is our VC cycle. 1, 2, 3, 4. Okay. Compressor inlet, compressor outlet. Condenser inlet, condenser outlet. Expansion valve inlet, expansion valve outlet. Evaporator inlet, evaporator outlet. देखो, the enthalpy at compressor inlet means H1 is 246. And the enthalpy at the compressor exit, this is compressor exit, 286. Heat load on the evaporator, very good. This is evaporator. What is the load on evaporator? 4 to 1. So therefore, the load on the evaporator is refrigeration effect. The amount of heat absorbed, there is a storage here. From the storage, it is absorbing heat. What is the load? 471. So H1 means H4, and that load is given as 158. And he is asking enthalpy at the exit of condenser. This is the exit of condenser. H3 is asked in the question. Very good, sir. H3 is asked. So can I write this as H1 minus H4 is equal to 158 evaporator load? But 3 to 4 is throttling. For throttling, H3 is equal to H4. So H1 minus H4. What is H4? H4 is H3 because it is throttling. It is 158. Already H1 is given as 246 minus H3 is equal to 158. So if I want H3, it will be 246 minus 158. 246 minus 158 is 88. What is 88? It is the enthalpy at condenser exit. So I think it is a fill in the blank question in 88. Let me check once, sir. एक बार मैं check. तब तक आप go to the next question. Yes. Next question. Please read this. Read this. Rigid tank. Whenever you see rigid tank, please put one thing, that is constant volume. Rigid tank initially at 1 bar and 300 Kelvin. ठीक है सर. The pressure is 1 bar and the temperature P1, T1, 300 Kelvin. It contains 5 moles of oxygen. Okay, ऐसा करेंगे सर. Let us take oxygen as 1. 1 ले लेंगे. Then nitrogen as 2 and hydrogen as 3. So let me write now. Let me write, my dear students. Look at N1. What does N1 mean? Number of moles of oxygen. It contains 5 moles of oxygen. Okay. N2. Number of moles of nitrogen. N2. Number of moles of nitrogen. 4 moles of nitrogen. Okay. Then N3. Therefore, there are 3 moles of hydrogen. Okay, sir. From this tank, listen carefully. Okay. From this tank, 2 moles of oxygen are removed. Okay. This is initial and this is final. 1 second, please. This is final. Okay. I don't know what is the final pressure. I don't know. But he says one thing. देखो एक बार कुछ बोला है सर. क्या बोला है सर? Keeping the temperature constant. He said keeping the temperature constant. So what is the final temperature, sir? The final temperature is keeping the temperature constant. Now, I don't know what is the final total pressure. Okay, no problem at all. How many moles of oxygen are removed? Look at it. Now N1 will become new N1. Here final. How many moles are removed? 2 moles are removed. Originally oxygen was 5 moles. Now 2 are removed. Left is 3. We are not changing other gases. Only oxygen is removed. Understand carefully. Only oxygen is removed. Observe. From this THIS, from this tank, 2 moles of oxygen are removed, keeping temperature constant. Assume ideal gas. Now he is asking, क्या पूछा है सर? कहाँ गया वो? The final partial pressure of oxygen is final partial pressure. Stop. PV is equal to N R bar T. Can I write this as certain parameters are constant, my dear students? What are those constant? Let us check once. Let us check once. इधर देखो. Volume is constant. R bar is constant. देखो. Let us take P by N. Now you tell me. P is the total pressure. N is number of moles. So I am applying for total. The total pressure is equal to. So can we write this as R bar T by V? Exactly. I can write. R bar is a universal gas constant. It will not change. T temperature. In both the cases, the temperature is same. And V rigid container. In two cases, that is initial and final, volume of the container is not changing because it is a rigid container. The temperature he only said remains constant, and R bar is anyway universal gas constant. Volume is a constant parameter in this rigid container. He said temperature is constant. Look at temperature is constant. R bar is universal gas constant. So I will write P by N in case 1 is equal to P by N in case 2. Okay. What is P1? 1 bar. Dear students, what is P1? 1 bar. What is N1? Total moles. Because it is the total pressure. How many moles are there? 5 plus 4 is 9 plus 3. Total moles are 12 in first case. I don't know what is the final total pressure. So how many moles are there? 2 are removed. 3 plus 4 is 7 plus 3 is 10. So can you tell me what is the value of P2? It is 10 by 12 bar. But he is not asking the final total pressure. The final total pressure is P2. He is asking partial pressure of oxygen finally. This is the final total pressure 10 by 12. You know very well the partial pressure is given by its mole fraction into total pressure. So the partial pressure of oxygen is mole fraction of oxygen into total pressure. Which total pressure? Because he is asking final partial pressure. So what is the final total pressure? 10 by 12 bar. The final total pressure is he is asking final partial pressure. Agar this is total, this is partial pressure of oxygen, तो ये oxygen होगा. So therefore, if he is asking final partial pressure of oxygen, it should be final total pressure. Now, can you tell me what is the mole fraction of oxygen finally? Finally, mole fraction is number of moles by total moles. So the mole fraction of oxygen is equal to final number of moles oxygen का 3 है, and the total is 3 plus 4 plus 3. 3 plus 4 plus 3. So this is nothing but 3 by 10 is 0.3. 3 by 10. So therefore, the partial pressure of oxygen under final condition is, this is 3 by 10. 4 plus 7 is 4 plus 3 is 6. Sorry, 4 plus 3 is 7 plus 3 is 10. 3 by 10. So 3 by 10 into, this is the mole fraction of oxygen. This is 3 by 10 or 0.3. Mole fraction of oxygen into 3 by 10, the mole fraction into 10 by 12. So it is 3 by 12, which is 1 by 4, that is 0.25 bar. So the answer is 0.25. Hope this is clear. Hope this is clear, because he has not asked partial pressure of oxygen initially. Final pucha hai, isliye I have taken the final pressure. Final total pressure is 10 by 12. Good. Next question. Good question. Take this question. Fixed mass means mass is not changing. Okay. Again, of an ideal gas undergoes 2 different cycles. This is cycle M and this is cycle N. ठीक है सर. गलत है सर arrow. It is clockwise. It is clockwise like this. It is like this. Both are clockwise, sir. Printing mistake है यहाँ पे. ठीक है, this is the cycle. ठीक है, there are two cycles given, both are clockwise. Now क्या पूछ रहा है सर? अच्छा क्वेश्चन है सर, एक बार पढ़ो. I request everyone to read. Fixed mass means in both cases the mass is same. Please read the question. मेरे प्यारे मित्रों, प्लीज पढ़ो दोनों. Come on, 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 come on. Read this, read this. Check. No. एरोस गलत हो गया सर यहाँ पे, बिकॉज ये भी क्लॉकवाइज है सर. Both are clockwise only, sir. Both are clockwise. Printing mistake, please. Now, it is PV diagram. What does closed area represent? What does closed area represent? It is a network. It is network. But from first law of thermodynamics, network is also equal to net heat. So this closed area is not only representing network, but it is also representing net heat. Because from first law of thermodynamics for a cycle, net heat transfer is equal to net work transfer. So let us calculate. So this closed area is not only giving you net work for this cycle M, but also it is giving you net heat. Similarly, it is for a cycle M. Similarly, this is giving not only the net work, but also net heat. Chalo, calculate karte hain, sir. Let us calculate the area of this cycle. So what is the area? Net area is, sorry, net work or net heat is area of the closed region. Here the closed region is triangle. Half base. पहला cycle ले लेंगे सर. I'm talking about cycle M. This cycle M. Half base. देखो अगर ये base है तो 2p1 minus p1. This is 2p1 and this p1. So 2p1 minus p1 into ये base हो गया और ये height है. ये base और ये height कितना है सर? 2v1 minus v1. This height, this side. This is the base, this is the base, and this is the height. Very good. What is this? 2v1 minus v1. 2v1 minus v1. And this will be half into p1 v1. That is the area of this cycle M. This is also net heat or network. This is nothing but net heat or network. But this is for cycle M. Now, let's go to this cycle. Again, network is equal to net heat is equal to closed area half base. This base is 2v1. This is also 2v1, sir. Printing mistake. This is also 2v1. Okay. 2v1 minus v1. 2v1 minus v1 is v1. 2v1. And this height is 2p1 minus p1 is p1. 2p1. This is 2p1 and this is p1. This is p1. Difference. 2p1 minus p1 is p1. 2v1 minus v1 is v1. This is 2v1 v1. Okay. So this is half p1 v1. So what is the indication? Both are same. So the net work or the net heat in both cycles is same. So heat input to cycle N is equal to heat input in cycle N. ये भी check करेंगे sir. Let us check this also. Let us check this also sir. तो पहले ऑप्शन को टिक करो. Heat rejected नहीं. Net heat transfer in cycle M is equal to net heat transfer in cycle N. This C option is correct. ठीक है sir. Now let us observe clearly. My dear students, if you understand, बहुत अच्छा सवाल है सर. Okay, I'll change the color. हाँ. Now this is the heat supply, sir. सुनो, it is at a constant pressure. This is also heat supply. देखो, in a ध्यान से सुनो सर. Common sense use करना. A to P is heat supply. How do you know it is a heat supply? Whenever the constant volume process is moving upwards, pressure is increasing. You know, PV is MRT, mass is constant, R is constant. For AB, volume is constant, pressure is directly proportional to temperature. Pressure is increasing, matlab temperature is also increasing directly. How is temperature increasing? By supplying heat. Here also, it is a constant pressure process. So it is a constant pressure process. PV is MRT. M is constant, R is constant, pressure is constant, volume is proportional to temperature. तो यहाँ पे देखो, what is happening? When pressure is constant, volume is proportional to temperature, volume is increasing. Volume is increasing means temperature should increase. How is temperature increasing? Heat supply. आंसर सुनो, इस केस में सिर्फ यहाँ पे सप्लाई हो रहा है और कांस्टेंट वॉल्यूम नीचे मतलब रिजेक्शन. Observe carefully. So there is a heat supply here only, but here heat supply is this and this. So definitely the supply is at constant volume in this and also at constant pressure. But here supply is at constant pressure only. So heat supply in M and N is not same. Answer suno sir. So is it clear sir? Supply is here and here. So this supply put together is more compared to this supply. So supply is not same. Net work is equal to heat supply minus heat rejection. ध्यान से सुनो my dear students. Supply, देखो, network is same. Look at carefully. Network is same in both the cases, but supply is not same. When supply is not same, how can the rejection be same? जब supply same नहीं, सुनो carefully. Listen carefully. Now I'll tell you one. I'll give you one simple example. इधर देखो. Listen first. I'll give you one simple example. 40 is equal to 100 minus 60. Correct. And 40 is equal to 120 minus 80. This is network, this is supply, and this is rejection. Look at it. In this case, supply is this and this, this and this, this and this. Supply is more. So supply is more. Very good, sirs. In this case, this is only the supply. So supply is less. When supply, network to दोनों में same आया sir. Network is same, but supply is not same. When supply is not same, rejection is also not same. Then only if rejection is same, how can the difference be same? This is not same. This should not be same because the difference should be constant. The difference should be constant. It means, now I'll tell you very clearly. QSM minus QRM is equal to QSN minus QRN. Look at carefully. When supply is not same, when these two are not same, so definitely these two are not same. Means supply is not same, rejection is not same, but the difference is same. And what is efficiency? Efficiency is net work by heat supply. In both the cases, numerator is same because closed area is same, network is same, network is same. But is the supply same? No. In one case, the supply is more. In other case, the supply is less. Even though the network is same, please do not conclude just by looking at network, the efficiency is same. If networks are same in both cycles, that doesn't mean the efficiency is same. It also depends on heat supply. In one case, the heat supply is more. In other case, the heat supply is less. So therefore, heat supply is not same. Even though the network is same, heat supply is not same. So efficiencies are not same. So heat supply is not same. Heat rejection is not same. Efficiency is not same. Only network is same. I can also prove that. How? You start a constant volume process, say, I can easily do, but not necessary. So this is the common observation. So what is the answer, sir? So heat rejection in M is equal to no. Heat rejection is not same. And efficiency is equal to no, it's not same. Then one more option is there. Heat input in cycle M, heat supply or input is same. No, only network is same. Is it clear? Good question, sir. Now, let's take 11th question. In a graph with Helmholtz function on y-axis, let us take Helmholtz function as f and volume on y-axis, volume on x-axis. Helmholtz function on y-axis, the slope of isothermal for a finite volume containing ideal gas. इसका slope पूछा है सर df by dv. लेकिन this he is asking for isothermal. So actually he is asking dou f by dou v at t. This is asked sir. ये पूछा है sir. Why are you writing dou? Whenever one parameter is kept constant, it will be partial derivative. It will be partial derivative because this term is evaluated at constant temperature. So he is asking the slope of Helmholtz curve with on y-axis, Helmholtz function on y-axis and volume on x-axis. So what is he asking? Slope पूछा है. Slope का मतलब dy by dx, dou f by dou y. So dy by dx is df by dy. But he is asking under isothermal. Whenever one parameter is kept constant, it will become partial. ये पूछा है सर. कैसे करेंगे? You want this value. चलो देखते हैं सर. देखते हैं सर. सुनो. Ideal gas. For an ideal gas, I can write PV is mRT. Very good, sir. Very good, sir. And can anyone tell what is P? Everyone knows. For an ideal gas, P is always absolute pressure. And everyone knows absolute pressure is always positive. There can be positive gauge pressure, there can be negative gauge pressure, but there cannot be negative absolute pressure. देखो एक बार, if this is zero pressure absolute, this is gauge. Gauge can be lower than atmospheric, upper than atmospheric, but absolute you cannot have. If there is no material medium, the pressure will be zero, but it cannot be negative. Absolute pressure is always either zero, perfect vacuum zero, absolute vacuum zero, or positive. Now you may be wondering, ये सब क्यों बोल रहा है सर? Just याद देने के लिए. And this temperature should also be in Kelvin. चलो, I know that कैसा अटैक करे सर? Always thermodynamic relations chapter is very important from XC point of view. This year I have done so many questions in my plus course. Recently I completed 2 days back. I have done so many questions on that, including van der Waals equation, compressibility factor, all those, and Clausius-Clapeyron equation. They are very important, sirs. Now, F और V है. कैसे करे? F is equal to U minus TS. Differentiate. Why differentiate, sir? This is Helmholtz function. Okay, differentiate. Why I want df? So df is equal to du minus tds minus sdt. Very good, sir. नहीं आया थोड़े लोगों को. चलो कोई बात नहीं. df is equal to differentiation of u is du minus uv principal t into ds plus s into dt. So I have opened the bracket directly. So df is equal to du minus tds minus sdt. Excellent, sirs. Now look at here. Please understand. I want the relationship between df and dv. एक बार देखो. tds is equal to du plus pdv. ठीक है, sirs. Now focus on this. What is du minus tds? Du minus tds is minus pdv. du minus tds is minus pdv. du minus tds is minus pdv. So df is equal to, what is du minus tds? Minus pdv minus sdt. चलो आगे देखो. f देखो, f, v और d. When temperature is constant, this is when temperature is constant, dt is zero. जब dt zero है तो ये उड़ जाएगा. तो df is equal to minus pdv और df by dv is equal to minus p. But actually I should write this as dou f by dou v. Q, because it is evaluated by keeping temperature constant. So T is minus P. Very good, sir. यही तो पूछा है सर. यही तो पूछा है सर. This is what he is asking. What is the value of this? Minus P. हमेशा आइडियल गैस में P पॉजिटिव रहता है सर. ये P वैल्यू इज पॉजिटिव बट माइनस अटैच हुआ सर. तो ये पॉजिटिव है तो ये वैल्यू क्या होगा सर? नेगेटिव होगा. ये वैल्यू क्या होगा सर? नेगेटिव होगा. सो ये वैल्यू क्या होगा सर? नेगेटिव होगा. सो देयरफॉर it is finite, negative and non-zero. It is finite, negative and non-zero because you cannot achieve zero absolute. देखो ideal gas के लिए definitely it will exert some pressure. So therefore वो गैस है बोला है. Whenever there is a medium, whenever there are molecules, you have a pressure. So therefore this is non-zero. This is non-zero. This is non-zero and negative. Finite means it has some value. So finite, negative and non-zero. Always zero, no. Infinite, no. Positive, no. This is D is the right answer. अच्छा question था sir. This is a good question. Next. Take this question. क्या बोला है sir? Match the following. ये बहुत आसान है sir. ये देखो मैं बताता हूँ. He has taken Helmholtz function as 5. In the problem, he has taken Helmholtz function as 5. I will take it as f. क्या फर्क पड़ता है? Wherever 5 is there, it is f. अब देखो सर, अभी तो बताया था. इधर देखो, just now I gave you df is equal to minus pdv minus, just now I gave you this equation. df is equal to minus pdv minus sdt. df is equal to minus pdv minus sdt. सुनो, he is evaluating this one set constant temperature, one set constant volume. इधर देखो सर, इधर देखो. But let us keep volume constant. What will be dv? 0. तो ये बन जाएगा df is equal to, when volume is constant, dv is 0. When dv is 0, it will be minus sdt. So this can be written as df by dt is equal to minus s. or minus df by dt is equal to s minus कर लेंगे. But actually I should write this as minus dou f by dou t. What is the reason for that? What is the reason for that? Why should I write this as minus? Why should I write this as minus dou? Because this is evaluated by keeping volume constant. One parameter is constant, so v, it is s. So actually he is taking Helmholtz function as psi. He is taking Helmholtz function as psi. लेने तो क्या फर्क पड़ रहा है? I took f, he is taking it as this. So therefore this is equal to s minus dou psi by dou t minus dou phi by dou t at constant volume. राइट है ना? दिख रहा है? minus dou phi by dou t, yes, at constant volume. ये वाला ये कहाँ है रे? मुझे समझ में नहीं आ रहा. अच्छा ये है, ये है कहाँ गया रे? कहीं पे मिस हुआ. चलो कोई बात नहीं. लेट मी चेक. कहीं प्रिंटिंग मिस्टेक हुआ? एक बार मैं चेक कर लेता हूँ. लेट मी चेक. इज देयर एनी प्रिंटिंग मिस्टेक? One second, please. एक सेकंड प्लीज. क्वेश्चन नंबर 12 ना. I'll check. Dou psi by dou y n1 n2 n3 n4 n5 n6 n7 n8 dou phi by dou vt dou phi by dou vt, correct, dou psi by dou tv minus this, okay, dou h by dou p n4 n5 minus dou h by no माइनस, ये माइनस नहीं है सर, ये प्लस है. n5 is dou h by dou ps. n6 minus dou h by dou sp. n7 dou h by dou p s. n8 dou h by dou sp. ये पूछा है सर. Now let's observe here. तो ये क्या है सर? माइनस डो फाई बाई डो टीवी, माइनस डो साई बाई डो टीवी, मतलब n4 इज मैचिंग टू व्हाट? एक सेकंड देखो. n4 डो माइनस डो साई बाई डो टीवी इज इक्वल टू s. s का मतलब कहां गया रे वो? s ये m1 m2 m3 m4. सो s is m3. तो m3 is matching to s कितना है? माइनस डो फाई बाई डो टीवी, माइनस डो साई बाई डो टीवी मतलब n4. ठीक है. नाउ विल टेक द नेक्स्ट वन. देखो, विल टेक द नेक्स्ट वन. सुनो, अभी तो बताया df इज इक्वल टू माइनस pdv माइनस sdt. एक बार चेक करना सर. df इज इक्वल टू, कहां गया वो? df is equal to minus pdv minus sdt, minus pdv minus sdt. Now let us take temperature constant. When temperature is constant, dt is 0. So df is equal to minus pdv, because when temperature is constant, it's 0. So df by dv is equal to minus p, or minus df by dv is equal to p. ठीक है सर. अब ध्यान से सुनो. But actually I should write this as minus dou f by dou v. What is the reason? Because this is evaluated by keeping temperature constant. So temperature constant, it is p. But problem में f को सही दिया है minus dou psi by dou v at constant temperature is p. तो p कहाँ है सर? p कहाँ है? m2. That is equal to minus dou psi by dou vp, dou vt minus dou psi by dou vt, मतलब ये n1 है. Yes, m2 is matching to n1. Excellent, sir. Now, let's take the other thing. Now, what is given in the problem? एक बार देखना sir. What is given? dH, dP, dH, ds. So, which relation is telling us all this? TDS is equal to TH minus VDP. Let us take pressure constant. What do I get? dP will be 0. When dP is 0, TDS is equal to dH because dP is 0, dP is 0. So dH by ds is equal to T or dou H by dou S. Why dou H by dou S? Because it is kept at constant pressure, that is equal to T. So dou H by dou S कहाँ गया रे वो? Dou H और dou H by dou SP. Dou H by is T. So therefore N8 is matching to dou H by dou SP is P. P का मतलब M4. M4. ठीक है सर. Now last one. Now you also know that TDS is equal to dH minus VDP. Now instead of taking pressure constant, let us take TDS is equal to dH minus VDP. Instead of taking pressure constant, now let us take entropy constant. Entropy constant. What do I get? What do I get? So when entropy is constant, ds is equal to 0. When ds is 0, ये तो 0 हो जाएगा, is equal to, when entropy, TDS is dH minus VDP. When entropy is constant, ds is 0. 0 into something is 0 is dH minus VDP. Okay, no problem at all. No problem at all. देखो, listen carefully. Now, dH by dP is equal to, ये इधर लाना, is V, or dou H by dou P, but this is evaluated by keeping entropy constant is equal to V. So, कहाँ गया सर? Dou H by dou P, dou H by dou PS, dou H by dou PS, dou H by dou PS, it is N5, N5, and that is equal to V. Where is V? M1. So, therefore, M1 is matching to N5, M2 is matching to N1, M3 is matching to N4, and M4 is matching to N8. So therefore, M1 is matching to N5, M2 is matching to N1, M3 is matching to N4, and M4 to N8. I think option C is correct. M1 N5, M2 N1, M3 N4, and M4 N8. Correct. Wonderful, sir. बहुत आसान सा क्वेश्चन था ये. Now take this question. Now यहाँ पे there is a mistake. Let me see. क्या दिया है? 13 क्वेश्चन. यहाँ पे मास मिस हुआ. Let me check. Question number 13. Here it is 10 kg. 10 kg water at 5:30 नंतर. 10 kg of water at 300 Kelvin is poured into a bucket containing 10 kg of water. क्या बोला है सर? There is a bucket. This bucket is containing 10 kg water at 350 Kelvin. Now, you know, my dear students, again 10 kg water is poured at what temperature? 300 Kelvin. Now, it is poured. Neglecting any losses to surroundings, मतलब surroundings से कोई losses नहीं. देखो, now my system consists of, actually in a bucket we have 10 kg water at 350. Now we have poured 10 kg water at 300. Definitely, even though the masses are same, temperature is not same. So finally, it will reach equilibrium. मैं दोबारा बता रहा हूं सर. There are two systems here. One is 10 kg water at 350. The other is 10 kg water at 300. Now, सुनो carefully. Finally, both reach equilibrium temperature. Whatever one system is losing, other is gaining. Heat lost by hot fluid is equal to heat gained by cold fluid. Correct na? Heat lost by hot fluid is heat gained by cold fluid. Correct. Now, what is the heat loss? Loss is initial minus final. Gain is final minus initial. So देखो, MC delta T of hot water should be equal to mc delta T of cooled water. Clearly in the problem, both masses are same. Water is same, so specificity is same. So what is the temperature difference of hot water? Finally, both are reaching same temperature. Hot water is losing from 350 and the final temperature is TF. Should be equal to temperature difference of hot water. It is losing, so higher minus lower. Second one, cold water is gaining. Gain का मतलब final minus initial. What is the initial temperature of cold fluid? It is 300. So therefore, तो ये हो जाएगा आपका 650 is equal to 2F. So therefore, the final temperature is 325. Actually, in examination, you should not do all these things. The reason is whenever masses are same, fluids are same. So final temperature will be average. ये तभी अप्लाई करो जब फाइनल masses are same. Sorry, when masses are same and specificity is same, then only it is average. Otherwise, no. Okay, sir. Let us calculate the total entropy change. He is asking entropy change. He is asking entropy change. Okay, no problem. For liquid, the entropy change is mc ln T final by T initial. But there are two fluids. One is the entropy change of hot water. Entropy is an extensive property. Whenever you want total extensive property, you should add. Whenever you want total extensive property, you should add. So therefore, the other is mc ln T final by T initial, and this is of cold water. So the entropy change is given by what is the mass? दोनों का mass, whether it is hot water or cold water. अरे liquid है, तो liquid entropy changes mc ln T5 and temperature should be in Kelvin. What is the mass of hot water? 10. Specific heat of hot water 4.2 into ln. The final temperature of hot water is 325 and the initial temperature of hot water is 350 plus m is 10 for cold fluid. Specific heat is 4.2 ln. The final temperature of both is 325 and the initial temperature of cold fluid is 300. Let us check the unit. ln has no unit. So mc, whatever unit you have for mc, same. M is in kg. Specific heat is kilojoule per kg Kelvin. So kg is gone, kilojoule per Kelvin. If you are calculating, I think you are getting this as ln 325 by 350 into 42.2393. गलत है ये, गलत है. So I think you are getting the answer as 0.249 kilojoule per Kelvin. Let me check, sir. Yes, it is correct. 10 into 4.2, 325. 10 into 4.2, 325 by 300. 325 by 300. 325 with, yes, 0.249. This is correct. Excellent. We'll move to the next one. A Carnot engine operates between two temperature limits T1 and T2 such that T1 is greater than T. So T1 is the source temperature and T2 is the sink temperature. The efficiency is increased by changing one of the temperatures constant and delta T greater than 0. Okay. Which of the following will give the highest increase in efficiency? Everyone knows the Carnot cycle efficiency can be increased in two ways. Either by decreasing the lower temperature or by increasing the source temperature. But he is very smart. He is asking, out of these two, which one is the best? देखो एक बार. I think option B can be easily ruled out. Decreasing T1, source temperature is T1. By decreasing T1, what is the efficiency of Carnot cycle? 1 minus T lower by T higher. Here the higher temperature is T1. The efficiency cannot be increased by decreasing T1. If T1 is decreased, denominator is decreased, this value will increase. Negative increase means efficiency decreases. So T1 should be increased. Decreasing T1, wrong. Decreasing T2 is correct. Increasing T2. Look at it. If I increase T2, this value will increase. Negative is increasing means efficiency will decrease. So increasing T2 is also wrong. It may be increased. Both are correct. But he is asking which one will give you the highest increase of efficiency. Suno carefully. Let us take case 1. Case 1. increase, sorry, case 1, decrease T2 by keeping T1 constant. What will be the equation? Efficiency, let us call this as 1. So 1 minus, what is T2 now? You have decreased by how much, sir? He only said delta T. Decrease matlab delta T. By keeping T1 constant. This is the first case. Let us take the second case. Case 2. Case 2. Increase T1 by keeping T2 constant. What is that? Second efficiency. 1 minus. We are not touching T2. We are not touching T2. Increase T1. So now, out of these two, which one will improve? Both will increase efficiency, undoubtedly. But which one is increasing more? He is asking. देखो sir, यहाँ पे. We can explain this with the help of graphs, that is slopes, or otherwise I'll give you a simple method. एक काम करते हैं sir. Let T1 be equal to 600, T2 be equal to 300, let delta T be equal to 20. Just an example. Now you tell me what is initial efficiency without changing. 1 minus T lower, it is 300. By T higher, it is 600. And this will be equal to 0.5. Okay. Now let us go for efficiency of 1. What will be efficiency of 1? 1 minus T2 is 300 minus delta T is 20 by T1. T1 is 600. So let us calculate this efficiency. It is 280. 280 by 600. So this is 0.533. Observe karo sir. Compared to 0.5, it is more. Now come to this. Efficiency of 2 is 1 minus T2. What is T2? 300. By T1 is 600. Plus delta T is 20. So it is 300 by 620. Here are 0.516. Now you tell me which one is more, sir? 0.53 means first case. What is first case? Decreasing T2 will give you more efficiency. Decreasing T2 will give it. अगर आप इसका difference ले लेंगे, आपको positive value आएगा. So what does it mean? If I calculate neta 1 minus neta 2, you get positive greater than 0. If I take difference, आप करके देखो. If you take the difference, it will be positive. What does positive means? What does positive mean? It means greater than 0. So efficiency of 1 is greater than, means first case efficiency is more, means by decreasing T2 by keeping T1 constant, this will give me more efficiency, sir. Very important. This can also be expressed with the help of graphs. कुछ मत करना, आप इसको differentiate करके देखना. One is getting the decreasing slope, other is getting constant slope. So decreasing slope is for T1 का आता है. So therefore, always remember, decreasing T2 will give me better efficiency. ठीक है sir. Let's go to the next. This is a good question. So please read this question. The equation of a state for non-ideal gas is given. PV by RT is equal to 1 plus B by P, where P is the pressure, V is the volume, of course specific volume, R is the gas constant, T is temperature. B is not constant. B is a temperature dependent parameter. Please note down that B is a temperature dependent parameter. For this gas, the partial derivative of enthalpy with respect to pressure at constant temperature, ये value पूछ रहा है sir. This value is asked. For this gas, which is following this relationship, the partial derivative of enthalpy with pressure at constant temperature, this is asked. बहुत सुंदर question है sir. He is asking this value. Actually, you should be very careful with such questions. What is the gas? PV by RT is equal to 1 plus BP. And why you need to be careful is, here B is not constant. B is a temperature dependent parameter. You should be very, very careful, sir. अब इसको कैसे करेंगे, sir? How to solve this? Now I'll tell you. Can I write this as PV is equal to RT into 1 plus dp, yes sir, or PV is equal to RT plus PP into RT. Okay. What do you want? देखो एक बार, differentiation of enthalpy with pressure. I know that enthalpy is equal to U plus PV. ठीक है sir. I know that. Why are you writing like this? Because I want this value dH by dP. So therefore enthalpy is this value. कोई बात नहीं sir. This is the gas. This is our given gas. It is not an ideal gas. So what do you want? H is equal to U plus PV. What is PV? इधर देखो, what H is U plus PV. What is PV? RT plus PP RT. Excellent, sir. Now you differentiate this. I want dou H by dou P at T. You differentiate this with respect to pressure at constant temperature. देखो, you differentiate this with respect to pressure at constant temperature. तो क्या होगा? It will be dou U by dou P at constant temperature. Very good. Look at carefully. You are differentiating this by T in temperature constant. R is a gas constant. Temperature is also constant. देखो, you are differentiating this by keeping temperature constant. Temperature is constant. R is constant. ये पूरा constant हो जाएगा. Differentiation of constant. This will be 0. Let me repeat. You are differentiating this at constant temperature. Temperature constant है. R is constant. ये पूरा constant है. Differentiation of constant. You are differentiating this, but ये पूरा term constant है. Why it is constant? R is a gas constant. T is already constant here. You are differentiating at constant temperature. ये पूरा constant. Differentiation of constant is 0. Plus B is a temperature dependent parameter. So therefore temperature is constant. तो ये constant है. R is gas constant. T is constant. Okay. Now P. You are differentiating with P. You are differentiating with P. What is the differentiation of P? 1. You are differentiating with P. P is a temperature dependent parameter. यहाँ पे तो constant है. R is a gas constant. T is constant. So you are differentiating with P. तो P का differentiation क्या होगा? 1. So therefore dou H by dou P at constant temperature is equal to dou U by dou P at constant temperature plus PRT. सिंपल है सर, लेकिन आंसर तो इट्स नॉट लाइक दिस ना. कुछ भी दिया है सर आंसर, डीपी बाई डी टी भी दिया है. कोई बात नहीं, सुनो केयरफुली. du TDS is equal to du plus PdV. Okay, or du is equal to TDS minus PdV. अब फोकस इस इक्वेशन पे रखो सर, बिकॉज इसको यूज करना है मुझे, इसको यूज करना है. ठीक है, TDS is equal to du plus PdV. du is TDS minus PdV. Okay, no problem at all. But what do you want? dou U by dou PT. इसको इधर देखो, डिफरेंशिएट दिस विथ रेस्पेक्ट टू P. दोनों तरफ P से डिवाइड करना, दोनों तरफ you divide both sides with P. देखो, tu is TDS minus PdV. Divide both sides with dP. Why are you doing? Because I want du by dP. But I want this to be calculated by keeping temperature constant. So therefore you keep this at constant temperature. ठीक है, देखो. Now the equation, can I find out dou V by dou P? Because V is given, I can find dou V by V as a function of P is given, I can find. But यहाँ पे S है, तो क्या करेंगे सर इसको? I want the value from this equation. Maxwell's equation use करना. I think one of the Maxwell's equations is this equation. One of the Maxwell's equations is this TV pass. तो ये हो गया सर. इसको उल्टा करो, you just reverse it. तो क्या होगा? dou V by dou T is dou S by dou P. Of course माइनस इधर ले लेंगे. तो this is also one of the Maxwell's equation. ये एक Maxwell's equation है सर. So I'm using Maxwell's equation. देखो, what is Maxwell's equation? Dou S by dou P. Maxwell equation यूज कर रहा हूं सर. डो एस बाई डो पी इज माइनस डो वी बाई डो टी। बट यहां पे ध्यान से सुनो, अगर यहां पे टी है तो टी इधर आएगा, टी इधर आएगा, अगर पी है तो पी इधर आएगा। सो देयरफॉर अब सिंपल हो गया सर, डो यू बाई डो पी एट कांस्टेंट टेम्परेचर इज टी इंटू डो एस बाई डो पी टी। व्हाट इज डो एस बाई डो पी टी? माइनस डो वी बाई डो टी पी माइनस पी इंटू डो वी बाई डो टी पी। चलो कोई बात नहीं सर। नाउ द प्रॉब्लम इज वेरी सिंपल। देखो v as a function of t is known, v as a function of t is known, so from this I can calculate, और ये कैलकुलेट करके यहां पुट करना, फाइनल इक्वेशन ये आएगा। चलो एक बार लेट्स कैलकुलेट दिस वैल्यू। माय डियर स्टूडेंट्स, लेट अस टेक दिस फंक्शन, डोंट बी इन हरी। तो pv by rt is equal to 1 plus bp. So what will be v sir? rt by p into, what is v? rt by p into 1 plus bp, और v is equal to rt by p plus, ये पूरा अंदर ले लो, bprt bprt by p. So this is gone. So v is equal to rt by p plus brt. Excellent sir. Now I will take this equation and go to the next slide. So v is equal to rt by p plus rt by p plus brt. इधर देखो सर, what do you want? एक बार मुझे डो v by डो t at constant volume चाहिए, एक बार डो v by डो p at, I want two things. What are those? डो v by डो t at constant p, डो v कहां गए? डो v by डो t at constant, डो v by डो t constant b, डो v by डो t constant b. What do you want? डो v by डो t constant, अरे डो v by डो t constant b. डो v by डो t कहां गया वो? Somewhere. Dou s by dou pt is dou v by dou t, it is constant p sir, I'm sorry. Dou v by dou t, dou s by dou pt is dou v by dou t constant p, constant p. ये ठीक है, constant p. Evaluate करो, you differentiate v with respect to t by keeping pressure constant. तो क्या होगा? Pressure is constant, r is constant, pressure is constant, r is constant pressure. You are differentiating with respect to t, t का differentiation is 1 plus. Here you are going to commit mistakes. R. Why are you not taking b constant? Because b is not constant, it is a function of temperature. Now you are differentiating with temperature. You are differentiating with temperature. R is taken out. R is taken out. Now we have bt. This is temperature. This, it is a function of temperature. It is temperature. So क्या होगा? B into, what is the differentiation of temperature? 1 plus T into, what is the differentiation of B? dB by dt. Let me repeat, sir. Let me repeat. So dou v by dou t is dou v by dou t. You are differentiating v with respect to t. So r by p at constant p, r, p is constant, r by p. Differentiation of t is 1 plus r is constant out, bt, b into differentiation of t is 1 plus t into differentiation of b is db. Why are you differentiating with b? Because b is not constant, it is a function of temperature. So dou, ये बहुत important है. Dou v by dou t p is equal to r by p plus br plus rt into db by dt. ये आ गया सर. Dou v by dou t p, r by p, br plus rt db by dt. Next क्या चाहिए? Dou v by dou pt. Dou v by dou pt. चेक करते हैं सर. Dou v by dou pt. Now you differentiate this v. देखो एक सेकंड, I have this. V is equal to RT by P plus BRT. I want dou V by dou P. You differentiate this equation with P by keeping temperature constant. So dou V by dou P by keeping temperature constant. So R is constant, temperature is constant. R is constant temperature. What is 1 by P? What is 1 by P? Differentiation of P minus 1 by P square. Plus ये पूरा देखो, B is temperature dependent. R is constant, T is temperature. So temperature is constant. It is only depending on temperature. When temperature is constant, this is constant. R is constant, temperature is constant. Different, ये पे temperature constant है. It is a temperature dependent value. R is constant, temperature. All these are constant because T is constant. Differentiation of constant is 0. So dou V by dou P at T is minus RT by P square. Put these values. ये ले लो. Dou U by dou PT. Dou U by dou P T is equal to T into, or I write minus T बाहर ले लो, minus T. So minus T into dou V by dou TP. Dou V by dou TP. It is R by P plus BR plus RT dB by dt. ठीक है. Then minus P into minus P into dou V by dou PT. Dou V by dou PT. It is RT by P square. ठीक है sir. So dou U by dou P at constant temperature is given by minus RT by P. ये अंदर ले लो. Minus BRT minus RT square dB by dt minus of minus plus ये P गया तो RT. Now put this value in this. इधर देखो. I want dou H by dou PT. Dou H by dou PT is equal to dou H by dou PT. Dou U by dou TP plus BRT. Dou U by dou PP plus BRT. Dou U by dou PT is minus RT by P minus BRT. Somewhere we have missed one. Minus कहाँ गया वो? Minus RT by P plus BR. तो ये plus RT by P. There is P here. I think this is gone. So therefore, let me remove this. This is gone. So we are left with dou H by dou P is dou U by dou P. So what is dou U by dou P? ये value minus BRT minus RT square dB by dt plus there is something plus BRT. So therefore, this is gone. Plus minus, you are left with minus RT square into dB by dt. Minus RT square dB by dt. Minus RT square dB by dt. This is a very good question. ये अच्छा क्वेश्चन था सर. नेक्स्ट ये करो. Now he says Brayton cycle. Isentropic compression, constant pressure heat addition, isentropic expansion, and constant pressure heat rejection. This is our Brayton cycle. This is occurring in compressor. This is occurring in combustion chamber. This is occurring in turbine, and this is occurring in okay. And this is occurring again in heat exchanger. ठीक है. Enthalpy at the turbine inlet H3 1400. Enthalpy at turbine exit H4 is 880. At the exit of compressor का exit H2, compressor exit, compressor inlet, compressor exit, turbine inlet, turbine exit, turbine inlet, turbine exit, compressor exit is H2 is 660. Sorry, 600. On adding, this is the original. What is the original heat supply? I'll write Q1. We are supplying heat from 2 to 3 constant pressure heat supply. So original heat supply, I'll write as Q1, H3 minus H2. So what is Q1, sir? H3 is 1400 and H2 is 600. What is the original heat supply, sir? It is 800 kilojoule per kg. Leave it. No problem at all. Now what he says? A regenerator is added whose effectiveness is 0.8. The absolute percentage change in heat addition. So before adding regenerator, this is the heat supply. Now if we add heat regenerator, definitely there will be reduction in heat supply. So देखो sir, ideally कितना gain कर सकता sir? Turbine exit compressor. So regenerator ideally कहां से कहां gain कर सकता sir? 4 से 2 तक. but it is gaining, let us say, if I add regenerator, let us say it is increasing from this. So the effectiveness of regenerator is given by actual gain by ideal gain. So from the turbine exit, it enters the heat exchanger and compressor exit fluid is coming like this, turbine exit fluid is coming like this, and there is a transfer. So ideally कहां से कहां आ सकता है ये T to H2 H4 तक आ सकता. So regenerator efficiency is given by HA minus H2. It is the ideal gain HA minus H2 by it is the actual gain HA minus H2 by ideal gain is H4 minus H2. So the effectiveness is 0.8. What is HA? I don't know, sir. What is H2? 600. What is H4? 880. What is H2? It is 600. Let me calculate. So this is 280 into 0.8 plus 600. It is 824. HA is 824. So what is the new heat supply? H3 minus HA. So pehle we were supplying from 2 to 3. Now you are supplying from A to 3. HA minus H3. HA minus H3. So therefore Q2 will be equal to HA. It is 824. H3 minus HA. I'm sorry. It is H3 minus HA. यहाँ से यहाँ supply कर H3 minus HA. So therefore H3 is, how much is H3? 1400 minus HA. What is HA, sir? Just now you have calculated 824. So minus 1400. तो ये आ रहा है 576. Before regenerator हम 800 supply किए थे. After regenerator we are supplying only 576. What is the percentage increase? Percentage change is always original के respect से what is the change. So therefore if you want percentage in 100, Q1 is 800. Final heat supply is 576 and original heat supply is 800 into 100. He is asking, but he is asking absolute, मतलब no sign, negative. There is a reduction in heat transfer. वो तो absolute बोला है. So therefore it will be 800 minus 576 divided by 800. And if you want in percentage into 100, it is 28 percentage. So the answer is 28. He is asking in percentage. I think he is asking in percentage. Is 28 correct? Let me check. Yes, it is correct. It is correct. Good. Let's go to the next question. This is a very good question, sir. Very good question. An ideal gas undergoes series of reversible steady state steady flow. It means it is open system. यहाँ पे बहुत important है sir. It is a steady state steady flow. Fluid is flowing, open system. Processes between 1, 2 and 3. Process 1, 2 satisfies 1 to 2 satisfies P plus 800 V 900. Okay. Now, अच्छा question है sir ये. Whereas pressure is in kilopascal, volume is in meter cubic kg, and 2 to 3 is isochoric. Means 2 to 3 is constant volume, isochoric. Constant volume. बोला है सर वो. He told. क्या बोला है इधर देखो. कहाँ गया है वो? 2 to 3 this. Given that V1 is 0.5 and V2 is equal to V3 is equal to 1. What is the total work per mass? Okay. First, let me represent. Whenever you want open system work, you will not project it reversible दिया है. Reversible means area under the curve calculate कर सकते. Whenever you want open, how do you know it is open system work? The fluid is flowing steadily. You can apply minus VDP or you project it on VDP का मतलब projection on volume axis. Minus VDP. Steady flow work is minus VDP. Minus VDP means projection on pressure axis. Projection on pressure axis. PDP is projection on volume axis. Okay. चलो 1 to 2 देखेंगे. Can we write P as 900 minus 800V? एक बार देखना. P as 900 minus 800V. How is it varying? देखो एक बार, P का और V का पावर 1 means it is linear. चलो, let me calculate P1. What is P1? 900 minus 800 V1. 900 minus 800 V1. ठीक है सर, because P1 V1, so P1 is equal to 900 minus 800. Already V1 is given as 0.5. 800 into 0.5 is 400. 900 minus 400, this is 400. 800 into 0.5 is 400. 900 minus 400 is 500. So the initial pressure is 500 kilopascal. And the initial volume is 0.5. So the initial point is known. And what is the final pressure? P2. P2 is equal to, because 1 to 2 is following this process, P2 is equal to, what will be P2? 900 minus 800 V2. I repeat, sir. P2 is equal to 900 minus 800 V2. So P2 is equal to 900 minus 800. The final volume is given V2 as 1. So 900 minus 800 is 100. So this pressure is P2 is equal to 100. And the volume is given as 1 meter cube. So V2 is equal to 1 meter cube per kg. And you know how is it, how the process is taking place. Dekho, power of P and power of V1. So this is my process. And what is 2 to 3? Dekho, what is 2 to 3? Kahan gaya wo? Constant volume. And please look at P3 by P2 is equal to 4. दिया है सर, दिया है सर. तो what will be P3 sir? 4 times P2, or P3 is equal to 4 times P2 is already known 100. P2 is already known 100. So P3 is equal to 400. So this is P3. But what is the volume? देखो देखो, at 3 the volume is same. It is a constant volume. So V2 is equal to V3. V2, V3 is 1. So this is the process. So 1 to 2 is this, 2 to 3 is this. Excellent, sir. Now क्या पूछ रहा है सर? देखो. He is asking total work. क्या करे सर? Blindly don't project on volume axis, because it is not a closed system. It is an open system. Either you follow minus VDP, integrate करो, तो आंसर तो minus VD का मतलब area only. So let us calculate the area of this. And one more thing, my dear students, it is very very important. Either you go for, मैं दो तरीके बताऊंगा सर आपको. I'll show you two procedures. एक second. I'll show you two things. For 1 to 2 process, what is the equation? What is the equation? P is equal to, कुछ दिया सर, P is equal P is equal to P plus 800 V is 900, or P is 900 minus 800 V. Okay, एक सेकंड, कहाँ गए रे वो? 1 to 2 process, it is P plus 800 V is 900. What is V? V 900 minus P, 900 minus P by 800. Correct na? 900 minus P by 800. So VDP minus VDP. And pressure is 1 to 2 cover. Let us calculate 1 to 2 work. So pressure is varying from P1 to P2. Pressure is varying from P1 to P2. P1 is 500, P2 is 100. P1 is 500, P2 is 100. I repeat. Why are you writing minus VDP? Flow work, steady flow work is minus VDP, minus VDP. अब calculate करो. Work in 1 to 2 is equal to, ध्यान से सुनो सर, सुनो. So minus बाहर ले लेना. तो 500 open system is minus VDP. तो V. This is 1 to 2 process. What is V? 900 minus P by 800 into DP. Excellent, sir. तो वर्क इन 1 to 2 इज 1/800 को बाहर ले लेना, इस 800 व्हाट इज 900 into dp 900p, नहीं आ रहा सर समझ में, इंटीग्रल dp is p, 900 into dp is okay minus pdp is p square by 2 and put करो what are the limits 500 to 100, तो ये आएगा W12 is equal to 1/800 into 900 100 minus 500 minus 1/2 into 100 square upper limit square minus 500 square, ठीक है सर। आप कैलकुलेट करेंगे ये वर्क, so this is minus 400 9 4 36 into 1 2 3 4, एक बार देखना ये 400 आ रहा है सर, 400 9 4 36 ओके करेक्ट, माइनस दिस इज 100 स्क्वायर माइनस ये आ रहा है माइनस 24 बट माइनस ऑफ प्लस 1200 आ रहा है कुछ, ठीक है, एंड देयर इज 1/800 आल्सो, तो 1/800 इंटू माइनस 36 1 2 3 4 प्लस आ रहा है ये प्लस 12, ये 12 1 2 3 4, ये कितना आ रहा है सर माइनस 24 by 800, this is coming out to be minus ये कहाँ है प्लस है माइनस VDP, माइनस तो भूल ही गए हम, माइनस तो लिए ही नहीं, माइनस को बाहर लिए, देयर इज माइनस 800, ये माइनस 800 डरो मत, ये माइनस को भूल गए सर, हम माइनस को भूल गए, तो कितना आ रहा है सर ये, आई थिंक दिस इज माइनस ये कैलकुलेट करेंगे तो प्लस 300 आ रहा है किलो जूल। ये सब करने की कोई जरूरी नहीं, क्यों दिखाया पता है आपको, जस्ट इसका एरिया प्रोजेक्ट इट ऑन प्रेशर एक्सिस, प्रोजेक्ट इट ऑन प्रेशर एक्सिस, ये वाला एरिया ट्रेपेजियम है, हाफ इनटू सम ऑफ द पैरेलल साइड्स, ये वाला कितना है सर 0.5 और ये वाला कितना है सर 1 इनटू ये साइड दिस साइड दिस इज 1 दिस इज 0.5 एंड दिस इज 1, ये 1 है ये 0.5 है इनटू डिस्टेंस बिटवीन देम, ये 500 है ये 100 है 400, कितना आएगा सर ये 0.6 0.3, समझ गया ना, half into sum of the parallel sides, that is this is 0.5 this is 1.5 into 400 divided by 2, ये आ रहा है 300, सेम आ रहा है ना सर, सेम आ रहा है ना सर, no need to calculate। next वाला let us calculate work in 2 to 3, again minus VDP, तो क्या होगा सर माइनस वॉल्यूम इज कांस्टेंट मित्रों 2 to 3, pressure is varying from P2 to P3, volume is constant, बाहर ले लेना, what is integral dp p, integral dp is p, p मतलब P3 minus P2, so therefore V into ये अंदर ले लो P2 minus P3, तो ये आएगा V is given as 1, P2 what is P2 100 and what is P3 400, this is 400, तो ये आ रहा है minus 300, this is the work in 2 to 3 minus, so what is the total work minus 300 plus 300, work in 1 to 2 plus work in 2 to 3 minus 300 plus 300 is 0 होना है, तो इधर भी देख लो सर, ये वाले वर्क देखो, लेट मी यूज डिफरेंट कलर, ये वाला इधर देखो, अगर 2 to 3 का वर्क चाहिए, ये एरिया कैलकुलेट करो, ये एरिया कैलकुलेट करो, प्रोजेक्ट इट ऑन प्रेशर एक्सिस, ये एरिया 400 minus 100 is 300 into ये लेंथ, ये वाला 300 है, दिस इज 300 एंड दिस इज 1, so it is 300, लेकिन आपको कैसे पता ये माइनस है, ऑलरेडी ये प्लस आ गया, कैसे पता है, बिकॉज व्हेन प्रेशर इज इंक्रीजिंग you are compressing, pressure is increasing from 2 to 3, you are compressing, so therefore work is done on the system, so in open system whenever the pressure is increasing it is a negative work, तो इधर देखो सर, now please look at here, इसमें P1 to P2 pressure is decreasing, so when pressure is decreasing तो ये वाला वर्क है पॉजिटिव वर्क, that's why I got it as plus 300, and ये वाला वर्क है compression negative वर्क, so total is plus, either you can calculate by area or VDP, but यहाँ पे word is flow. Some students have in projected it on pressure axis, ये बहुत इंपॉर्टेंट है. The answer is 0. इसका आंसर 0 है क्योंकि ये ओपन सिस्टम है. अच्छा सवाल है सर. नेक्स्ट ये करो. This is a very good question. Air is assumed to be an ideal gas with a mass flow rate of 2.5 kg per second. The mass flow rate is given as 2.5 kg per second. ठीक है. In a horizontal nozzle, देखो enters the horizontal nozzle at a temperature of 350 Kelvin and the pressure is 350 kilopascal. And the velocity is given as 3 meter per second. The air exits the nozzle at a pressure of 101.5 kilopascal and a temperature of 305 and a Mach number of 9/7. Assuming steady state operation and constant properties, the ratio of inlet area to exit area required to satisfy the condition is, and he has given gamma is 1.4, Cp is 1.011, not 005, and R is given. यहाँ पे क्या mistake करेंगे? I'll tell you, sir. What mistake you are going to commit? Let me tell you. The mass flow rate is given by rho AC. It is a steady flow. है ना sir? It is a steady flow because nozzle is a steady flow device. Nozzle is it enters a horizontal nozzle. It's a steady flow, sir. Okay, nozzle है तो steady flow. Now, steady flow mass flow rate is same. Rho 1 A1 C1 is equal to rho 2 A2 C2. He is asking A1 by A2. What will be A1 by A2? Rho 2 C2 by rho 1 C1. ठीक है sir. Now, can I calculate the density here? It is an ideal gas, sir. Air is assumed as an ideal gas. PV is MRT. So P is equal to M by V RT or P is equal to rho RT. So rho will be equal to P by RT. One more thing. Whenever R is in kilojoule per kg Kelvin, P should be in kilopascal. So rho 1 is equal to P1 by RT1. So let me calculate inlet density P1. It is 350 kilopascal. Okay. For air, R is 0.287. And what is the temperature, sir? Temperature is given as 350. So I'll use ready-made values which I have obtained. So therefore, कितना आ रहा है sir? 350 by ये आ रहा है rho 1 is equal to 3.4843. Rho 1 is known. C1 is already given. Now, I want rho 2. What is rho 2, sir? Rho 2 is equal to P2 by RT2. Hold on. So rho 2 is equal to P2 is 101.5 and R is 0.287 and the temperature is 305. So 101.5, 0.287 by 305 and you get rho 2 as 1.1595 kilogram per meter cube. So rho 2 is also known. C2 चाहिए. कैसे करेंगे सर? C2 चाहिए. कैसे करेंगे? Some students said steady flow energy equation. ठीक है sir. Apply steady flow energy equation. H1 plus C1 square by 2000 plus Z1G by 1000 plus Q is equal to H2 plus C2 square by 2000 plus Z2G by 1000 plus W. Nozzle work कभी नहीं मिलता है, लेकिन यहाँ पे problem क्या है ना? He has not given this as adiabatic nozzle. Had it been adiabatic nozzle, Q would have become 0 and directly I would have calculated C2. From here I would have calculated H1 is CPT1, H2 is CPT2 and C1 is given. Potential horizontal है तो potential changes are neglected. So if it is adiabatic nozzle, I would have directly calculated by taking Q0. But यहाँ पे वो नहीं कर सकते sir, because some information is given. If that information is also not given, if Mach number is also not given, I would have taken adiabatic. But यहाँ पे some students, what they did in exam, you know, they neglected this Q and took it as 0 and calculated C2 and then they put, that is galat sir. क्या करेंगे फिर? तो एडियाबैटिक नोजल नहीं दिया है तो ये यूज ही नहीं करेंगे। मुझे पता है सर, मैक नंबर इज इक्वल टू, देखो, v बाई सुनो वेलोसिटी बाई sonic velocity. This I had taught very beautifully in our regular plus courses. मैं अपने plus courses में बहुत ही बढ़िया पढ़ाया था। तो क्या लिखेंगे? m is equal to velocity, अगर m2 है तो c2 by sonic velocity is gamma rt. I have derived this equation sir. मैं अपने compressible fluid flow chapter में इसको derive किया और ये भी बोला कि r should be in joule per kg per Kelvin. बहुत clarity से बताया सर. Why it is taken like this? What is the Mach number given? It is 9/7 is equal to C2 by, this is the definition of Mach number. Gamma is 1.4, R is 287. One student said, sir, why not 0.287? I had explained very clearly. Joule per kg is also meter square per second square. Joule per kg is also meter square per second square. Therefore, root of joule per kg is root meter square per second square meter per second. So it should be in joule. ये सब मैं क्लास में बताया था. And what is T2? What is T2? 305. So यहाँ से I get the value of C2. From here I get the value of C2. That is 9/7 is equal to देखो 9/7 into 1. ये 305 है. Where is the Mach number given? Exit. So you should take exit temperature. So exit Mach number is given. So exit यहाँ से C2 आएगा. C2 is 450. बहुत important है सर. Mach number is equal to, I have taught very clearly in compressible flow. So V by C. तो बैक नंबर, ये सी को सोनिक वेलोसिटी बोलते हैं सर. सोनिक वेलोसिटी, द सोनिक वेलोसिटी फॉर एन आइडियल गैस इज रूट गामा आरटी. तो C2 by रूट गामा आरटी, ये डेफिनेशन ऑफ मैक नंबर है सर. तो मैक नंबर इज गिवन, तो दिस इज 5/7. तो यहां से आई गॉट C2. पुट करो सर, पुट एवरीथिंग हियर. व्हाट इज A1 by A2? रो टू C2, रो टू 1.1595, रो टू A1 by A2 is equal to रो टू C2. Rho 2 is 1.1595 into C2. What is C2? You have calculated from Mach number by rho 1 C1. What is rho 1? What is rho 1? 3.48. 3.48. 3.4843 into C1. Rho 1 C1. From this, you put all values or not, just put C1 is 3. तो यहाँ से कितना आ रहा है सर? I think you are getting 49.9. Roughly it is 50. This is a very good question. So you know where are you committing mistakes? That is very, very important. Is it okay? Right. Next question. ये अच्छा सवाल है सर. Look at the melting point of a substance at 1 bar is 273 Kelvin. The density of solid is 900 kg per meter cube. And the density of liquid is 1000 kg per meter cube. The latent heat is given as 300 unit kilojoule per kg. Assuming that the above properties are constant, the melting point at a pressure of 101 bar, and he is asking melting point, that is temperature T2. I have given you Clausius-Clapeyron equation. You know very well. But I have taken liquid vapor. मतलब कहां से गए हम? Liquid vapor means Fg. Whenever it is Fg, it will be Sg minus Sf. But यहाँ पे solid to liquid जा रहा है. तो solid to liquid का मतलब क्या है? Instead of G minus F, it will be L minus S. L minus S. L minus S. It is vapor minus liquid. G minus F, तो L minus S होगा. तो वेपर के प्लेस में लिक्विड लेगा, लिक्विड के प्लेस में सॉलिड लेगा. यहाँ पे बहुत अच्छा क्वेश्चन है सर. डू यू नो द इक्वेशन? dP by dt is equal to LH by T into Vg minus Vf. But this is for liquid to vapor. But here it is not liquid to vapor. It is liquid to vapor नहीं, solid to melting बोला है, solid to liquid. तो यहाँ पे आएगा V liquid minus V solid. Vg minus Vf, G minus F, V liquid vapor, solid liquid. तो G के प्लेस में L आएगा, F के प्लेस में solid आएगा. ठीक है सर. But यहाँ पे specific volumes are not given, densities are given, but specific volume is reciprocal of density. But before that, let me rearrange. dP is equal to dt by T into LH by VL minus VS. क्लैरिटी से बोला है, properties are constant. Above properties are constant. These properties are constant. तो इसको integrate करो. What is so P1 to P2, T1 to T2. What is integral dp? P upper limit minus lower limit. What is dt by t? Log t. Log t2 minus log t1 is log t2 by t1 into LH by V liquid minus V solid. ठीक है सर. Now, can I write this as P2 minus P1 into ये इधर ले लेना. P2 minus P1 into V liquid minus V solid by LH. V liquid ये इधर लेना is ln T2 by T1. Absolutely. But you should be very careful. This latent heat is given in kilojoule per kg. So pressure should be in kilopascal. P2 is 101 bar. P1 is 1 bar, but this is in bar. 1 bar is 100 kilopascal. I have multiplied with this. And VL, what is specific volume of liquid? 1 by 1000. Dekho, density is given, not volume. So volume is equal to specific volume is 1 by density. Specific volume of liquid is 1 by this minus specific volume of solid. Solid क्या है? 1 by specific. Specific volume is 1 by density. तो ये solid का 900. And the latent heat is, what is the latent heat, sir? 300. And that should be equal to ln T2 by, already T1 is given 273. All these are in Kelvin. If I calculate, my dear students, let me 1 by 1000 minus 1 by 900 into 1 divided by 1000 minus 1 divided by 900 into 1, 2, 3, 4 divided by 300. ये आ गया. तो इसका ये ले लेना. This value is coming out to be, ये पूरा कुछ आ रहा है, मैं एंटी लॉगरिथम ले रहा. तो into 273 ये आ रहा है 271.99 Kelvin. So therefore it is 271. 272 लिख सकते सर. राउंड ऑफ बोला, राउंड ऑफ. अच्छा 2 डेसिमल, चलो 272 लिख सकते सर. Is it okay? Now हो गया सर. We are left with only 3 questions. Next. ये करो. This is a very good question. 20th ले लेना. बाद में हम 20th ले लेंगे. 20th ले लेना. 100 moles of moist air at 70% relative humidity. These are saturation temperatures, saturation pressure, saturation vapor pressure. Okay, मैं बताता हूँ. What is this? This is from RAC, psychrometry. अच्छा क्वेश्चन है सर. It's a very good question. 100 moles of air at 70% relative humidity is cooled to 70, cooled from 70 degree at 250 degree. We are cooling it from 70 degree to 50. पहले हम, what is the relative humidity initially? It is 70%. So I rate this as 0.7. 70%. And how many total moles? 100 moles of moist air. मतलब total. And total moles, moist air का मतलब liquid plus vapor. That is, sorry, moist air का मतलब dry air plus water vapor. This is actually, moist air means dry air plus water vapor. What do we have in dry air? Oxygen, nitrogen, helium, ये सब. So total कितने moles दिया है सर? 100 दिया है. ठीक है. Now, is cooled from 70 to 100 at a constant pressure of 1 bar. The total atmospheric pressure is 1 bar. That is 100 kilopascal. 1 bar is 100 kilopascal. That is fixed. ठीक है. At 70 degrees centigrade, the saturated vapor pressure is PVS is 31.1 thing. At 50 degrees, it is 12.34. पहले आप initially ले लेंगे. We know that phi1 is equal to PV by PVS. Initial की बात करें. You know that relative humidity is PV by PS. So what is the initial relative humidity? 0.7. PV1 by PVS. At initially, what is the temperature? 70 degree. At 70 degrees, at 70 degree, what is PVS? 31.16 kilopascal. 31.16 kilopascal. If this is in kilopascal, this will also be in kilopascal. Tell me the value of PV1. 0.7 into 31.16. 21.8 kilopascal. This is the partial pressure of vapor initially. ध्यान से सुनो सर. The total atmospheric pressure is 1 bar. बहुत ध्यान से सुनो. The total pressure is 1 bar. The total pressure is 1 bar means 100 kilopascal. What do we have in total air? Dry air and water vapor. So total pressure of air is equal to partial pressure of dry air plus partial pressure of vapor. अगर ये इनिशियली है तो ये PA1 ये PV1 होता है. एक्सेलेंट सर. एक्सेलेंट सर. सुनो केयरफुली, आराम से, टेंशन नहीं लेने का. तो what is the total pressure, my dear students? Total pressure is 100. Can you tell me what is the partial pressure of dry air? देखो, the total pressure is 100. The partial pressure of dry air plus vapor का pressure है 21.8. तो ये आ रहा है 78.2. So the partial pressure of dry air initially is 78.2. The partial pressure of vapor is 21.8. The total moles is equal to, ध्यान से सुनो, the total moles is equal to 100. मतलब ये दोनों का मिलाकर. बहुत बढ़िया. Can I calculate when the total moles are known? Can I calculate the total moles of before that? ये बहुत conceptual question है सर. I consider this question to be a very good question. अब देखो, ठीक है सर. Initially the temperature is 70 degree and very simple sir, moist air at 70%. Whenever the relative humidity is other than 100, it means it is in superheated state. ये तो RAC में पढ़ा है सर. So therefore this is the initial point. Here the relative humidity is, so this is the partial pressure of vapor. तो ये partial pressure of vapor, ये PV कितना दिया सर? 21.8. देखो देखो, when you are cooling, ये प्रेशर पूरा हो गया 21. आंसर सुनो सर, कितना मस्त क्वेश्चन है सर. एक सेकंड, I'll explain. Don't worry, logically I'll explain. This is a constant pressure line. Everywhere it is 21.8. सुनो सर, what is the? It is cooled to what temperature? It is cooled to what temperature? 50. 50 पे PVS कितना है? 12.34. 50 पे PVS है 12.34. 50 degrees. इधर देखो, 50 degrees. And this is our 12 point something. Why are you taking this? Because ध्यान से सुनो सर, ये पूरा प्रेशर 21 पॉइंट समथिंग, ये पूरा प्रेशर 21 पॉइंट समथिंग, कांस्टेंट प्रेशर कूल 21 पॉइंट, ये 21. तो डेफिनेटली ये टेम्परेचर 50 नहीं होगा सर, बिकॉज 50 होने के लिए द सैचुरेशन टेम्परेचर इज 12 पॉइंट समथिंग. इसका मतलब हमारा एयर कूल होके यहां टच करके कंडेंस हो रहा है सर. अदरवाइज, क्योंकि द पार्शियल प्रेशर ऑफ वेपर इफ यू सी इनिशियली is more than this, इससे 12.3 से ज्यादा है, तो वो आके यहां टच होगा और ये वेपर लूज करेगा, फाइनली इट इज रीचिंग सैचुरेशन. आई रिपीट सर, वो बिकॉज अगर यहां पे होता है तो डेफिनेटली व्हाट इज द प्रेशर हियर, फॉर एग्जांपल व्हाट इज द प्रेशर हियर, इट इज 21.18. बट व्हाट इज द टेम्परेचर हियर? मेरा सैचुरेशन प्रेशर यहाँ पे है 12.34. 12.34 मींस इसको टच होके नीचे जाना है, इसको नीचे जाना है, मतलब कंडेंसेशन हो रहा है सर. फाइनली इट इज इन सैचुरेशन स्टेट. फाइनली कंडेंस होके वो सैचुरेशन रीच कर रहा है, रीच होके पूरा वेपर लूज कर रहा है. एंड द फाइनल सिचुएशन इज, ये बहुत कॉन्सेप्चुअल क्वेश्चन है सर. द फाइनली इट इज, ये आरएसी का है. जो लोग सिर्फ थर्मो की अभी नया बैच वाले, इसको छोड़ दो अभी. देखो फाइनली the total pressure is 100 because it is cooled at, वो प्रेशर को चेंज नहीं हो रहा, टोटल तो 100 है. ध्यान से सुनो सर, फाइनल पीवी कितना होगा सर? PV2, बिकॉज वो तो सैचुरेशन रीच कर रहा है सर. फाइनल यहाँ पे रीच हो रहा है, फाइनली इट इज रीचिंग 50, तो सैचुरेशन रीच हो रहा है, बिकॉज अदरवाइज इट कैनॉट बी विदाउट रीचिंग दिस पॉइंट, इट कैनॉट रीच दिस, तो कंडेंसेशन हो रहा है सर, कंडेंसेशन हो रहा है, तो फाइनली इट इज पीवीएस, तो ये 12 पॉइंट कितना है सर, फाइनली वो रीच हो रहा है पीवी2 12.34, 50 डिग्रीज पे वो 50 को आ रहा है सर, या टच होके लूज करके इट इज लूजिंग मॉइस्चर एंड रीचिंग दिस, फाइनल रिलेटिव ह्यूमिडिटी 100% है सर। अब इसको कैसे करें सर, वो बोल रहा है हाउ मेनी आ गया, हाउ मेनी मोल्स ऑफ वाटर इज लेफ्ट इन दिस, मतलब ये नंबर ऑफ मोल्स ऑफ वेपर, वाटर मींस वाटर वेपर, ओके पूछा है सर, कैसे करेंगे, one thing is not changing, what is that not changing, dry air number of moles are not changing, इससे मैं क्या करता हूं, ध्यान से सुनो, partial pressure of dry air by total pressure is equal to mole fraction of dry air under initial conditions. Mole fraction is number of moles of dry air by total number of moles. Let me repeat, partial pressure of dry air by total pressure will be the mole fraction. आपको क्लास में बताया था सर, whenever you want the partial pressure, it will be mole fraction into total pressure. तो अगर आपको x चाहिए, it will be partial pressure by total pressure. Partial pressure of dry air by total pressure will be equal to the mole fraction of dry air. But what is mole fraction dry air? Number of moles of dry air by total number of moles. Already I know. What is PA? It is 78.2 by what is the total pressure, sir? Total pressure कितना है? The total pressure is 100. Should be equal to number of moles of dry air by total number of moles. What is the total number of moles? It is 100. तो इसका मतलब the number of moles of dry air is, ध्यान से सुनो सर, number of moles of dry air is 78.2, and you know very well dry air mass is not changing, only liquid mass is, vapor is condensing, तो vapor condense हो रहा है, तो dry air mass is 7, dry air यहाँ पे अगर 78.2 है, number of moles is a representative of mass, तो अगर मास चेंज नहीं हो रहा ड्राई एयर का, ओनली वेपर इज चेंजिंग, तो यहां पे भी इट विल बी 78.2. एक्सीलेंट सर, वेरी गुड. नाउ कैन आई कैलकुलेट, ध्यान से सुनो सर, अब देखो, let n be the total number of moles, let us calculate total number of moles, let n be the total number of moles, and you know the partial pressure of what is the partial pressure of dry air sir, इधर देखो, the total pressure is 100, ये फाइनल का, the total pressure is 100 is equal to partial pressure of dry air plus partial pressure of vapor 12.34, तो यहां से मिल रहा है 100 minus 12.34, तो ये आ रहा है 87.66. ठीक है, so what is, I will calculate total moles. So therefore, तो देखो, partial pressure of dry air by total pressure is equal to mole fraction of dry air. Mole fraction का इक्वेशन ये होता है, दोबारा बता रहा हूं, partial pressure of dry air by total pressure will be equal to mole fraction. But what is mole fraction? Number of moles of dry air. This is the mole fraction of dry air. ठीक है, PA2 is 87.66 and the total pressure is not changing. वो बोला है 100 बोला है. So number of moles of dry air by total moles. Already dry air moles is, यहाँ पे already I know dry air moles. The dry air moles is 78.2 by total number of moles. यहाँ से total moles आ जाएगा, कितना आएगा सर? N is equal to, एक सेकंड, into 78.2 into 100. तो ये आ रहा है total moles is 89.2. So out of 89.2 total moles, 78.2 is dry air. So out of total moles is equal to number of moles of dry air plus number of moles of water vapor. यही पूछा है. So total moles is 89.2 and number of moles of A2 कितना है सर? कहाँ गए? Total moles is number of moles of dry air. A2 कितना है सर? 78.2. ये तो ये A2 फाइनल कंडीशन, A1 हो या A2, dry air is not changing. Dry air is A1 और A2, dry air is not changing. 78.2 plus number of moles of this. तो this minus 78.2, ये आ रहा है आपका 11 moles. It means 11 moles of water vapor is left in the container. He is asking how many moles of water is left in the container. It is 11 moles. Wonderful question. The answer is 11. Answer is 11. Have you understood? अच्छा सवाल है सर ये. Next. There is one more. ये वाला. Let's take this question. We are nearing, sir. Don't worry. A rigid insulated tank containing ideal gas at 301 bar. There is a tank contains ideal gas at 300 Kelvin and 1 bar. ठीक है. Now, insulated, sorry. Clearly बोला है insulated. ठीक है. No, is filled with externally pressurized supply line. एक supply line है. From supply line, it is filled with the help of valve. Let us see what are the supply line conditions. It is 310 bar. Here the temperature is 300 and the pressure is 10 bar. Okay, sir. And how long it is filled? When the mass of the gas is doubled, what is the final temperature? So, ध्यान से सुनो sir. An insulated tank contains an ideal gas, is filled from external sample, supplying the same gas. So, if there is oxygen, it is also supplying oxygen. How long? Until the mass inside is doubled. Originally, the mass is m1 and final mass is doubled. Now, let us take this. It is unsteady state filling process. Apply unsteady state equation, sir. Apply unsteady state equation. dm by dt in the control volume is equal to m dot I minus m dot E. He is asking the final temperature. क्या बोला है वो? कहाँ बोला है सर? When the mass in the final temperature पूछा है. So in the control volume, so let me take control volume as this tank. So when I open the valve, it is entering. There is only inlet, there is no exit. From this, no mass is leaving. E का मतलब exit, no mass is exiting. So dm by dt in the control volume is equal to m dot I. Excellent, sir. And let me apply energy equation. du by dt in the control volume is m dot I hi plus q dot minus m dot e he minus w dot. From the tank, you are not getting anywhere. Insulated, heat transfer is 0. No mass is leaving, exit mass is 0. So du by dt in the control volume is m dot I hi. Let me substitute m dot I value here. So du by dt in the control volume is m dot I. What is m dot I? dm by dt in the control volume into hi. Excellent. Now you integrate this with respect to time. When you integrate with time, ये time निकल जाएगा. So it will be delta u du. It will be delta m in the control volume. ये control volume का है sir. ये control volume into hi. What does hi mean? Inlet conditions. Ti is inlet pressure. Yeah, inlet temperature. ये inlet conditions है. Ti is 300 and pi is this. Okay. What is the change? It is final minus initial. What is the change? Final minus initial into hi. आराम से कोई टेंशन मत लेना. U2 can be written as, specific volume is total by mass. So U is equal to m into U. U2 is m to U2. U1 is m1 U1. That is equal to m2 minus m1 into hi. Very good. But m2 is given, final mass is given as twice the initial mass. m2 is 2m1. U2 is CVT2. m1. U1 is CVT1 is equal to m2 is 2m1. m2 is 2m1 minus m1. hi. What is hi? Ideal gas CPTA. For ideal gas, U is CV2. Therefore, M1 is gone. 2 CVT2 minus CVT1 is equal to 2 minus 1. 2m1 minus m1 is m1. m1 cancel. So CPTI. So I will write this as CV common So 2T2 minus T1 is equal to CPTI. So 2T2 minus T1 is equal to, ये CV को इधर लेना, CP by CV is gamma Ti. Excellent. 2T2. What is T1? The initial temperature in the tank is 300. Gamma is 1.4. Ti is 300. So this will be 1.4 into 300 is 420. 420. ये 300 इधर जाएगा. 420 plus 300 is 720. So 2T2 is 720 and T2 will be equal to 360 Kelvin. A good question. T2 is 360 Kelvin. Last question. Last question, sirs. ये वाला पढ़ो एक बार. Read the question. A piston cylinder contains 2 kg of wet steam. ठीक है सर. 2 kg of wet steam at 90 degrees with quality. Initially, it is in wet region. ठीक है सर. Now, it is loaded with linear spring and the steam expands to 800 and 250. 800 and 250. Okay, on heating, we are heating. Actually, in this piston cylinder arrangement, and there is a spring, there is a wet steam. मतलब यहाँ पे liquid vapor mixture है. On heating, the volume is increasing. So, what is the final condition? Final pressure is 800 kilopascal and final temperature is 250. So, the final volume is given, final specific volume. The final pressure is 800, final temperature is 250. So, at 250 degrees and 800, the volume is 0.29 final volume. Can I calculate initial volume? Yes, sir. Initially, it is in wet region. Whenever it is in wet region, it is Vf into Vg minus Vf. Let me calculate V1. What is Vf? 0.001. Initial drainage fraction is given as quality का मतलब drainage fraction 0.1. Vg minus Vf. Vg is 2.4 and Vf is 0.001. So let me calculate first. 2.4 minus 0.001 into 0.1 plus 0.001. It is 0.2409 meter cube per kg. Excellent, sir. And he is asking work. And it is a linear spring. The initial pressure is 70 kilopascal because initially it is in wet region at a pressure of 70 and the final is 800. देखो एक बार. Initial pressure is 70 kilopascal. The final pressure is 800. Initial volume is 0.2409 and the final volume is 0.29. 0.24 say 0.29 is more. This is the initial pressure, initial point, and this is the final point. And it is a linear spring. We have done thousands of questions. It's the linear spring, so therefore it varies linearly. I have derived how it is linear. So therefore, work chahiye. It is a closed system. For closed system, what is the work? Project this, calculate this area of trapezium. He is asking work. Work is equal to area of trapezium. Calculate karo. Half into sum of the parallel sides. It is 70, it is 800 into distance between them. So it is 0.29 minus 0.2409. Check the unit. This is in kilopascal and this is meter cube per kg. So Newton meter is joule, kilojoule per kg. But the answer is asked in kilojoule. So whatever you are getting, it will be for 1 kg. But I want total. What is the mass? Multiply with mass. So you will get in this. So kitna aa raha hai sir? 0.29 minus 0.2409 into 870. This is 42.717 kilojoule. So this is the answer. Thank you, my dear students, and I'll come up with many more such sessions. Thank you, and please share your views. Thank you.